I keep seeing this fucking video. I want to say like 7 people have sent this to me. And it keeps getting recommended to me as well. Fine. Fine. I'll watch the fucking video. Witch Hat Atelier is actually really good. No, I've not seen it. It just keeps getting recommended to me. Not at all important to this video, but there is like dumb Twitter drama about this series. I don't fucking know. I don't care enough at this point. I like the series. I think it's fun. And this video, I guess we'll see what this is. I feel like this could make like an interesting concept for a game. I don't know.
This is a spell simulator I built based on Witch Hat Atelier. The idea is simple, actually. You draw the glyph, keep the ring open, and nothing happens yet. But when you close the circle, the program tries to read the drawing, compile the spell, and cast it. And if you're watching Witch Hat Atelier...
Because it, like, I could imagine it being... So, what's... I think it's like 2 or 3 different games like this. The spell game, the wizard game where you have to run around shouting spell names. A bunch of VTubers were playing it. I forgot what it's called. But I think something like that actually could like something like this could actually make a fun chaotic streamer game.
This season, you probably already know why I wanted to build this. If you haven't watched it yet, no worries. I'll explain the basic idea. But just in case,
there are 2 different ones.
Spoilers about how the magic system works. Also, just to be clear, this is a fan-made experiment. I'm not trying to recreate the canon magic system perfectly. I just wanted to see how far I could turn the idea into something interactive.
That's not the one I'm thinking of.
It's basically about a girl named Coco. A humble dressmaker's daughter has always been fascinated by magic and the witches who cast it, despite the strict precautions they take to hide their methods from the public. At first, magic looks like something mysterious that only special people can do. But later, the story reveals that magic has rules. It felt less like random fantasy magic and more like science or even programming. In this world, spells are cast by drawing glyphs. A spell usually has 3 important parts: a sigil, signs or keystones, and an enclosing ring. The sigil is kind of the main element of the spell. For example, fire, water, wind, earth, or light. The signs are like modifiers. They affect how the element behaves, like direction, shape, movement, spread, or maybe how the spell is controlled. Then there's the ring. The ring is really important because the spell only activates when the circle is complete. So a witch can prepare a spell by drawing almost the whole thing, leaving a small gap, and then closing the ring later. It legit does feel
like programming. Definitely, yeah.
Activate it. That idea is so cool to me because it makes the spell feel almost...
I do think this is like a very interesting magic system. Like a lot of series, they kind of... They'll be like, oh, the magic is in the ancient language, and the ancient language is just English. But they never really like dig too far into it. I can't think of another series, at least off the top of my head, that sort of digs that much into its magic system. It's a nice change of pace. It is nice to see a series actually approaching a established genre and then doing it a slightly different way. Like, the only thing I can think of that kinda did that, to like a little bit of an extent, was like Harry Potter with the thing for the Dementors. Where it's like, the stronger your memory is, the stronger the spell is. But I can't think of anything else off the top of my head that really explores their magic system like as much as this does. Like, that's the core focus of this series.
It's like a program waiting to run. The logic is already written, and closing the ring is basically pressing enter. And yeah, Coco is not the only one fascinated by this magic system. I was too. Okay now, even if paper and ink can't do that, a computer kind of can. You know where this is going. Because if the magic has rules, then we can try to simulate those rules. And if you come from programming or coding, you might notice...
Which has basically effort made, but the transmutation circles have logic behind them.
Something interesting. The magic in Witch Hat Atelier, it's like a visual programming language. Basically,
I guess
drawing
so.
the glyph is like writing the source code. Completing the ring is like running the program. And in the anime, the world just understands the spell because, well, it's magic. But a computer doesn't understand anything. It just sees messy lines on a canvas. So, before I could make any fire or water effect, I first had to make the program understand what was actually drawn. So in this video, I'll show you how I built this Witch Hat Atelier spell simulator. It's still just a proof of concept. For now, it only understands a small dictionary of simple sigils and signs. It also only supports one main ring at a time, so this is more like a tiny prototype language. But it can recognize some basic glyphs, detect when the ring is completed, compile the drawing into spell parameters, and then render a simple magic effect. I also made a GitHub Pages version, so you can try it yourself right after watching this. And if you're interested, the source code is already public on
This does feel like it is the basis for a streamer game. It actually really does.
GitHub too. The code is rough in some places, but I think it's good enough to show the idea. And honestly, I learned a lot from building this. So let's talk about how the project works. I won't show live coding here because this isn't really meant to be a coding tutorial. Also, it would take way too long, and I don't think anyone wants to watch me debug canvas coordinates for half an hour, right? Instead, I'll explain the bigger picture. The project itself is pretty simple technically. It's just static HTML, CSS, and JavaScript, but the structure behind it is the important part. I separated the UI from the input system. The UI folder is mostly for canvas layout, tabs, buttons, and diagnostic panels. The input folder is more focused on the actual drawing data, like strokes, points. That separation helped because the visual interface can change later, but the stroke data should still stay consistent. The first thing I needed was a dictionary. The dictionary defines the basic sigils and signs, what they are, where they can appear, and what they mean. Then I needed a parser, so the program can look at the drawing and figure out things like where is the ring, what is inside the ring, which strokes might be a sigil, and which strokes might be signs. I also treat the ring as the boundary of the spell. The parser can tell which strokes are inside or outside the ring, and only the drawing inside the ring gets recognized as part of the spell. Anything outside it gets ignored because otherwise random strokes around the canvas could accidentally become part of the magic. For now, I also don't support
I don't know how that works in the actual series. Like, if there is a sigil near a ring, does that apply to it, or is it only stuff that's inside the ring? I don't know if that's actually addressed ever in the series.
Multiple rings in one spell. The app looks for one main activation ring, then tries to understand what is inside it. After that, I needed a compiler. The compiler takes the parser output and turns it into the meaning of the spell. For example, instead of hard coding every possible spell combination, I wanted the program to output parameters like element, direction, force, spread, stability, and duration. Then the renderer takes those numbers and turns them into a visual effect. The renderer is separate from the rest of the system, so later I can replace the simple effect with a better renderer without rewriting the parser or compiler. So let's start with the dictionary. This is basically the language definition. For example, the fire sigil means fire, a column sign might mean the spell should become more focused, like a beam or a stream. The important thing is that the dictionary should not care how the symbol is recognized or how the final effect is rendered. It only defines the meaning of the visual language. I also kept a small list of observed spells from the anime so we can use as drawing references. But after defining the dictionary, I also had to decide the limitations for this proof of concept, because Witch Hat Atelier can get complicated.
Well, yeah, in the latest episode, for example, they just addressed, oh, what happens if you draw the sigils backward for the spell that turns things into dust? Well, what happens? It turns the things that were in dust, that were turned to dust, back into their original forms. Right. I have a feeling some of the rules are gonna feel kinda like bullshit. But I guess we'll see.
Really quickly. Even in the first episode, we are already shown more advanced looking spells, including drawings that...
I do wonder if the author actually has fully mapped out the system or if some of it is kind of just bullshit for the moment, right? Because this feels like one of those things which could very well be bullshit, but could also be, I have fully mapped out how the system functions, right? Because there are series out there that have entirely fake languages. And it is internally consistent. I don't know how much of a psycho the author is.
Have rings inside rings. For now, I'm not handling that, as I said earlier. The app only supports one main ring on the canvas. It does not try to understand multiple rings in one drawing or a ring inside another ring. I also don't really handle strokes that start outside the ring and go into the inside, even though some cases might still work with tolerance. The hardest part by far was the drawing recognition. I knew this part wouldn't be simple, but I didn't expect it to be this much harder than I imagined. Real drawings are messy. Sometimes people redraw lines, correct curves, they make the same stroke thicker. The circle is most of the time not a perfect circle, like this one. So the code has to figure
immediately kills everyone in the anime.
Things like, is this a ring? Did the user just close it? Which strokes are inside or outside the ring? Is this a fire sigil? Is this a levitation sign? And so on. The ring detector itself is mostly geometry with tolerance. The code looks for a circle-like stroke, estimates the center and radius, then checks if the stroke is close enough to a ring. But detecting whether the ring is actually closed was surprisingly annoying. At first, I tried checking the arc angles and the missing gap. It kind of worked for clean drawings, but with messy hand-drawn rings, it kept making mistakes. Sometimes the code said the ring was closed, even though
I guess you'd want fairly high tolerances for the closure, but I don't know how you'd address that.
there was still a very obvious gap. Then I opened MS Paint to draw some test sigils, and I remembered this old fill bucket tool. If a shape is closed, the fill stays inside. If there is a gap, the fill leaks out. And that made me realize I could use the same idea for the closure detector. Instead of only asking, does this stroke cover enough angles, I could ask, if I flood fill from outside the candidate ring, does the fill get into the inside? If the inside stays dry, it means the ring is closed. If the fill leaks into the inside, then there is still a gap. It sounds almost too simple, but it worked much better for the kind of messy drawing I was testing. There is one compromise though. I also needed a minimum ring area, because some small closed signs or sigils can accidentally look like tiny rings. Without that check, the code might think a small symbol is the activation ring. The whole parser took a lot of time, but the sigils and signs were, a different kind of headache. For the symbol recognition, the code works in a few stages.
Yeah, you can probably spend months trying to tweak exactly the criteria for what is and is not every single possible element.
First, it looks at the strokes inside the ring, ignores the ring itself, and then groups nearby strokes into a candidate symbol. So if I draw something like this column sign, for example, the vertical line and the horizontal base can be treated as one candidate, because their boxes overlap or their endpoints are close enough. After that, the grouped symbol is compared against the known sigil and sign templates. The code normalizes the drawing into a small square, then turns both the drawing and the template into a tiny raster image, basically a small ink map. Then it checks things like how much of the drawn ink overlaps the template, how much of the template is missing, and whether there's extra ink where there should not be. The final score is just a weighted mix of those checks. So things like overlap, missing template ink, and a soft similarity score all contribute.
We love magic numbers.
This makes the recognizer a bit more forgiving than exact stroke matching, because we can draw slightly messy and still match the intended shape. Signs also need one extra step, because where they sit around the ring matters. The templates are stored as if the sign is sitting at the bottom of the ring. So if the user draws the same sign on the right side, the recognizer rotates the drawn sign back toward the bottom position before matching it. But this is also one of the limitations of the current version.
Right, and then how you deal with then you got to do some fun math to work out where in the circle it is. Like if you're doing like just cardinal directions, that's fine. But then if you're doing like 45s between that's fine. But if you're then trying to go like anywhere in the circle, Now you got to do some math.
Version. If a sign is on the right side of the ring, but it is intentionally pointing inward, the current
Oh yeah, also inverted symbols. Didn't even think of that one.
recognizer will not understand that correctly. I know the anime can do things like that, where orientation and placement can change the meaning of the spell. But for this, I'm only handling the simpler version, so a sign has an expected orientation based on where it sits around the ring. The recognizer still allows a small rotation wiggle after that, so slightly messy drawing is okay. After that, the recognizer compares the candidate against every known sigil and sign template in the dictionary. Each comparison gets a score, so the code is basically asking, does this grouped stroke look more like fire, water, column, or something else? Then it picks the best match, but only if the score is above that symbol's threshold. That threshold is important, because without it, the recognizer would always try to guess something, even when the drawing is just random messy ink.
Right.
So if the best match is strong enough, the candidate becomes a recognized sigil or sign. If not, the app just treats it as unknown and ignores it for now. The recognizer also keeps a few measurements, like how big the sign is, how stretched it is, how long the ink is, and whether it has a strong main direction. That becomes useful later, because a bigger or more elongated sign can affect the spell differently. So the recognizer's job is mostly to say, okay, this looks like a column sign, and here are some useful measurements. Then the compiler can decide how strongly that sign should change the spell. I tried working on the symbol recognition with both Claude and Codex. It worked okay for clean drawings, but it was not really good enough for messy lines. And the problem is that people don't draw symbols perfectly. They redraw lines, make corrections, draw signs too close together, or place things in slightly weird positions inside the ring. I also considered using a small machine learning model, something like a doodle classifier.
That would make sense.
But then I realized I would probably need to train it again with my own messy glyph drawings. And even after that, classification alone would not be enough. The code still needs to know the orientation of the sign, where it is placed inside the ring, and what happens when two signs are drawn close together. It's just the same headache. So for this proof of concept, I decided that was not worth it yet.
Okay.
Instead, I made the parser replaceable, so later I can swap in a better recognizer without changing the dictionary, compiler, or renderer too much. As long as the parser outputs the same spell structure, the rest of the app doesn't really care how the recognition works. Once the parser has done its job...
This is built excessively sensibly for like a kind of throwaway project.
The code still can't just immediately throw fire on the screen. At that point, the code only knows what it thinks the drawing is. Like, okay, there is a complete ring. There is probably a fire sigil. This sign is facing outward, and the confidence score is around this much. But that is still just the code describing the drawing. So I turn that parser result into something I call a glyph AST. AST stands for Abstract Syntax Tree, which sounds very programming language compiler-ish, but in this project it just means a structured version of the glyph. So instead of messy strokes, the app now has a cleaner description of what was drawn. Then the compiler turns that glyph AST into spell IR. IR means intermediate representation. Again, it sounds a bit scary, but the idea is actually simple for this project. I used this term because I wanted the code structure to match the spirit of the magic system, a visual language that gets interpreted before it turns into an effect. Okay, so spell IR doesn't really care about the lines anymore. It cares about the spell parameters, like the element is fire, the shape is a column, the direction is upward, the force is high, the spread is low, and the stability is medium. And once the spell is in that form, the renderer finally has something useful to work with. It can take those parameters and turn them into the actual effect on screen. Great. The last step is the renderer. This is the part that actually draws the magic effect on screen. In the project, I put this in the renderer folder, and inside that there is an effects folder for the sigil-related visuals. So fire can have its own effect logic, water can have its own effect logic, and later other elements can be added without changing the parser.
He's the mythical 10x
At least
engineer.
that is the idea.
He did mention he's using Claude or Codex. I think he said Codex for this, for like some parts of it.
Experiment with UI,
like obviously this is someone who still
cleanup, and small
has a
visual
math
details.
background.
And for that kind of thing, it was pretty useful. I didn't want to go too deep into physics simulation here. As long as the result looked good enough to represent fire, water, or light, that was enough for this proof of concept. The spell structure was already there, so I was not asking it to invent the whole system. I was more like, okay, here are the spell parameters. Now help me turn this into a stream of water.
Honestly, even, like, not even just for this project, looking at the code base is probably a sensible idea to consider how to actually modularize a code base. Even if you're doing something entirely different, the way that he's thought about this problem applies to tons of other things you might want to do.
Or a stream of light, or make the water feel more cohesive. And even then, I had to be pretty specific with the words. If I just said something vague, the result usually became vague too. And if you've ever worked with AI, you probably see this a lot. But for a proof of concept, it was enough to show the important part. The effect is not hard-coded directly to the drawing. It comes from the spell parameters. So later, if I want better fire, better water, or even a completely different renderer, I can replace this part without throwing away the whole project. So yeah, here is the current result. Again, this is still a proof of concept, not a perfect simulator, but the basic idea works. I can draw sigils, signs, leave the ring open, and nothing happens yet. Then when I close the ring, the spell activates. If the drawing is cleaner, based on the quality calculation parameter, the result is more stable. If it's messy, the spell can fail, like this one for example. So yeah, that is the current version of the simulator. It is still rough, but I learned a lot more from this project than I expected. At first, I thought I was just making a fun anime-inspired spell toy. I wanted to keep it simple, but the more I built it, the messier it became. Suddenly, I was thinking about shape recognition, stroke grouping, normalized coordinates, confidence scores, flood fill, and compiler ideas like AST and IR, which is
basically a game, yeah.
A lot for a magic circle that still fails if I draw it too badly. But that is also what made it interesting. So maybe later people can contribute better templates, better recognition, more accurate signs, or even better spell effects. For now, this is my attempt at turning Witch Hat Atelier magic into a real program. If you want to try the demo or look at the code, the links are in the description. And if you have ideas for better recognition, better spell rules, or more accurate signs, I'd love to hear them. Thanks for watching.
That was fun. That actually was pretty fun. I was not sure what to expect from that. Every time we watch like a programming video like this, it makes me want to actually stop being lazy and actually go and build something. Like, I've got these ideas for things to work on. It's just a matter of I start doing something and then I just give up relatively quickly.